4.5, number 221. We have the function f of x equals sine x plus sine cubed over the interval negative pi to pi, not inclusive. So we're supposed to find the intervals where f is increasing and decreasing and the local minima and maxima of f. So basically, it's apply the first derivative test. That'd be a more concise way to describe that. Test. All right, so we need the first derivative. F prime of x will be derivative of sine is cos. So that becomes cos, and we have sine cubed, which is a composition of the sine function inside the cubic function. So the cube will come down first, got the power rule on the outside. Inner function stays the same, power goes down by 1 to sine squared, and I multiply by the derivative of the inner function sine to become cos on the outside there to finish the chain rule. All right, we know whether this is equal to 0 or undefined. Now, given that it's just a sum of sine functions and cosine functions, there's no way it'll be undefined. So I'm going to write it here, but really we don't have to worry about that at all. Okay? But it's something in general to pay attention to. So we're really just worried about equal to 0 in this particular case. All right, so where's the equal to 0? We'll try to factor it and solve. So it looks like we can factor off a cos, and that would be a good idea. At least get that much done. So cos x, and then we have 1 plus 3 sine squared left over. That's equal to 0. So you have two options. Either cos x is equal to 0, or the other factor, 1 plus 3 sine squared is equal to 0. All right, so we start to solve each one. When cos x is equal to 0, that means x must have been where? For cos to be equal to 0, x must have been here, or all the way around to here. So if we're going from negative pi to pi, right, these would be the terminal sides. The terminal sides are hard to see because they're on the y-axis, right? But you have a terminal side here, you have a terminal side here. That's where cos will be 0. So within this particular interval of negative pi to pi, all right, so that's from back here, negative pi, right, negative pi, all the way around to pi. Well, measuring back here, the only location where you'd have this terminal side would be negative pi on 2. So we have one solution right now for this one. X is negative pi on 2. Right, so we're starting out back here at negative pi, and we start to sweep around. The first location we'll hit is negative pi on 2. And as we go further and go around to pi, the second location we hit is right here, this terminal side, but that'll be at pi on 2. So these are the two locations where cos will be 0 over this particular interval. Now we try to play the same game with 1 plus 3 sine squared. So we start to solve that. What you should start to recognize is that this is not even possible. 1 plus 3 sine squared equals 0 can't happen. The reason it can't happen, and to forego this attempt at algebraically solving here, sine squared is always positive, right? Because it's a square. Forget the actual values of the sine function here. Just know that you're dealing with a square on a function or a value. You know that this at least is always positive or 0, right? So this part here is always greater than or equal to 0. And so now you've got 1 plus, at worst case scenario, this is 0, right? And anything above 0, it's gonna be positive, right? So you got 1 plus something which is basically positive or 0. There's no way that 1 plus something 0 positive could ever become 0 itself. So this is what I would call a red herring. There's nothing to look for here. This is not a valid equation. There's no solution here. So we have already found the two critical values from the first factor, and they are the only two critical values because nothing emerges from the second factor. This is something to watch out for in general. You start trying to solve equations that seem reasonable at first, but if you just think about them a little bit, they're not reasonable, and they produce no critical values whatsoever. So let's just write down here the critical values. We have found negative pi on 2 and pi on 2.